Testing, testing, 1, 2, 3. Yeah? You want to be in the stream today? Alright, come here. Oh. Alright. Yeah, I know. So, there we go. My cat wanted to be in the stream today. Actually, he probably wants, like, water in his water bowl, but that's okay. Okay. I think, yeah, good. Good. I just forgot to plug in my bloody microphone. That's all. There we go. All right. Cool. Yeah, just utterly destroy that like button, please. And if you haven't subscribed to the channel, please subscribe to the channel, because I am tantalizingly close to getting the 1,000 subscribers I need to become a real channel, and, you know, monetize my old videos and all of that kind of stuff. So, please subscribe to my channel. Please do it. No pressure. No marks for subscribing, though. That would be considered corruption. And you know, there's probably enough of that in the world already. Anyway, so I don't think we have any announcements to talk about with respect to this class. Oh, I should mention the timing of the virtual tutorial, actually. So, ta-da! We're going to have, two policy modifications since last week. Number one, virtual office hours. So the way that I've decided to handle the virtual office hours this semester is I'm going to run the virtual office hours at the same time as the in-person office hours. So but I'm going to extend this time slot from it used to be 1:30 to 2:30 on Thursdays. It's now going to be 1:30 to 3:30 on Tuesdays. Thursdays. Was I saying Tuesday? I'm sorry, I meant Thursday. 1:30 to 3:30 on Thursdays. So basically I'll have my computer running and I'll have the Teams thing going on my computer, and feel free to log in at any point in that or show up at any point in that, and we'll just kind of queue people in the order that they appear, regardless of whether they show up electronically or in person. I will try not to exercise too much meet person privileges. So anyway, virtual office hours. You asked for it, and here it is. Also, virtual tutorial. So, of the 3 classes I'm teaching, I believe this is the class with the fewest number of people who signed up for the virtual tutorials. So, the poll came out as a tie, so I asked the TA who's going to be doing the class which slot was preferable, and she said Thursday 3:30 to 4:20. It will be recorded via the Microsoft Teams recording service thing, so if you can't make that slot, you'll be able to catch it afterwards. But yeah, that's when our virtual tutorial is going to be. So there you go. Hopefully that makes sense to everyone. Let's see. I need a stream on Twitch so you can send Twitch Prime sub. Yes. You have a driving lesson this week during the tutorial. How much of a problem is that? Well, I wouldn't recommend engaging in your tutorial at the same time as taking a driving lesson, no. You should probably do one and then do the other. So The real answer to your question is, by not engaging in the tutorial synchronously, you lose the same thing you lose by not engaging in this lecture synchronously. You lose the ability to ask questions at the time. However, we do have the Piazza Forum, which in theory will be, people will be answering questions on that, so there you go. Will office hours also be recorded? No, I don't generally record office hours because people prefer the privacy. Is there a in-person tutorial this week as well? Yes, so one of my TAs indicated to me that apparently some profs are instituting some policy where the first 2 weeks are virtual tutorials, and then after that there'll be in-person tutorials. Not in this class, baby! In this class, we're going to jump immediately, feet first, into the in-person tutorials and hopefully hold it for the entire semester, assuming there aren't any more government lockdown mandate thingies which would preclude such a thing. Which, while it would be, silly for the university to have brought people to campus in the first place if there was just going to be another lockdown, I've kind of, at this point, I'm planning for both eventualities. This is kind of like, I would advise, oh, is he in the background again? Yeah. Hello, Bubs. His actual name is Martin, but we call him Bubs. Hey, Bubs. I have learned to not, I would advise everybody to, enjoy being able to go to school in person, because in the view of at least this professor, I wouldn't be surprised, I basically view this whole semester as being, they could mandate that the in-person component be removed at any time, so enjoy it while it lasts, And if it lasts for the whole time, even better. But, I have told all of my TAs to be able to move to online tutorials instantaneously, so everybody is prepared should that happen. Because who the hell knows. But anyway, are in-person and virtual both mandatory? No. Nope, it's one or the other, my friend. It's one or the other. Is there a tutorial after this lecture, and is it in person? There is. I actually don't know the schedule. I don't have the schedule written down, but yes. Yeah. So, anyway. What, online school being a scam? Listen, don't get me started, okay? I'm just letting you know that this is what I've done to prepare for certain eventualities. As your professor, I'm going to try to not let anything catch me, by surprise this semester. And that means a little bit of over-planning. So, hopefully it doesn't come to that. Yeah, you'll have to check your own schedules. I have no idea when or where the tutorials are. Well, I guess I could just check the syllabus, couldn't I? Boop. Well, yeah. You guys could also check the syllabus, but since I'm already here. Yeah, it is directly after this. Physically, it's in ABB Basement 118. So, if you're not used to location, room numbers that have the B in front of it, in general, this is how room numbers work at McMaster, because, you guys, you're a class who never actually did, this is your first in-person university, I think. So, if your room number has a B in front of it, then that means it's in a basement. If it has an A in front of it, then that means it's in an annex. So some buildings, like ITB, which is the building that I inhabit, have an annex where all of the room numbers have A prefaced it A is a prefix on half the room numbers in the building because half of them are in an addition that was built on the building later. So just be careful about that, because you're not going to have much time to get to ABB from your current location. Though, if you are one of those people who is watching from Thode right now, ABB is the one that's right next door to you, so there you go. ABB is the one that has the chemistry labs, like the undergraduate chemistry labs in it. But anyway, so let's continue on with our lecture. I think I've wasted enough time today. Yeah. So basically, if you see any letter prefixing a room number other than B, that means it's an annex. But I think there's also there's an app for finding your way around campus, which I think is good. Where do you attend the tutorial from online? From your computer. So, we're talking about C. We're talking about the intro to C. So, let's talk about standards and implementations. I touched on this last time. Oh, yeah. So, yeah, a room number like 102B is different from B102. B102 means you're in the basement. 102B means that there are two rooms, like 102A and 102B, that are right next to each other on the first floor. Yeah. I mean, if you're hypothetically watching the lecture from any location, it would make sense to watch one, okay, so here's a trick, okay? I'm gonna hack the university for you right now. If there's nobody in a room and there's not a class going on in it, you can just sit there. You don't actually have to be in a library. So in theory, you guys could watch the lecture from your tutorial room so long as it's not being used. And most of the rooms on campus aren't being used at any particular time. Oh, what platform? It's going to be on MS Teams. The virtual tutorial is going to be on MS Teams. Yeah, thank you, AJ. All right, so let's talk about C. I mentioned this last time when I was talking about how C basically blew up the whole software community with this new fangled idea called standardization. So, standards and implementations. The semantics of the C language are set by the International Standards Organization, ISO, and the International Electrotechnical Commission in a series of standard documents. The most recent one, at least the most recent one that I've checked for, is C18. The C standards come out like every 5 or 6 years, and there's usually minimal changes. Although C99 was pretty big because that introduced Booleans. If you can imagine it, before that, C didn't have any Booleans. So, yes. So it's ISO/IEC 9889 or 9899 2018. You are not required to read this document. We are going to go through C programming as this course, so you don't need to know. You don't need to do that. But anyway, there are many C compilers, which are all implementations of the above standard. The following compilers are compliant with the latest version of the standard, and they are the only ones that are compliant with the latest version of the standard according to Wikipedia, which should, in theory, be accurate. GCC, so that's the GNU Compiler Collection 8.1.0. This is the one that you have to worry about. Clang is IBM's version, and I'm not sure who runs eWarm. ISO stands for International Standards Organization, so it's not, hey, game ROMs, that's not, yeah. No, it's not like an ISO disk. It's not a file format. So, like many other languages... Oh, wait. 1 second. So, I just want to mention briefly that... so, Microsoft, if you're using VS Code to do C programming this semester, you should be aware that the C compiler that Microsoft uses is not fully compliant with the latest C specification. So Microsoft's C compiler is not compliant with the specification. So for the type of stuff we're doing, that shouldn't matter. It's kind of very edge case type stuff where there will be a difference between Microsoft's C compiler and GCC. But you should be aware that there is a difference, and you should be aware that in order for your work to be considered correct, it needs to compile under GCC. Again, the overwhelming majority of Microsoft, programs written for the Microsoft C compiler will compile under GCC. However, if you're the kind of person who likes to double and triple check things, it wouldn't be a bad idea just to make sure that GCC doesn't choke on your program, because GCC is the one that we'll be using. So, like many other languages, the unit of abstraction in C is the function. So in C, there are no classes, right? C is not an object-oriented language. C++ is an object-oriented language. C++ has objects and classes. But C has only functions and things called structures, which are basically multiple variables which have been bound up together and given its own unique data type. So you should be thinking functions when you're programming in C. The most commonly used functions are collected into the C standard library. The documentation may be found at this link. Let's follow this link, shall we? There we go. The GNU C Library Reference Manual. So this is the reference manual for GCC specifically. But there's a reason they call them the standard library. The standard library functions will be standard across C implementations. So there you go. You can install GCC for VS Code. Yeah, probably. But, Or you could just use a proper operating system and do it right from the command line. But, yes. Incidentally, I'm a little bit annoyed with what I'm seeing of people abbreviating command line interface to CLI because it makes it look like it's another language. It's just annoying. Anyway. So, use of library functions is strongly encouraged. If there's a library function for what you want to do, you should use the library function before you write your own function for it. Now, whenever anybody is learning a new programming language, you're going to do a certain amount of re-implementation of library functions. This kind of teaches you the language, and at the same time, you learn the libraries as you're learning the language. But the C Standard Library has over 50 years of development that has gone into it, and are among the most reliable and stable library functions in all of programming. You just have to, use them. But, that's kind of, you should use the standard libraries. They have, decades of optimization and improvement. Rule 1. If a library exists, use it. Rule 2. Learn Rule 1 quickly. That's a reference to the Karate Kid. So, we're going to go through a number of languages which have been based on C over the years. Yes, you should figure out how to log into Piazza for sure. So, C++ is the most obvious language that was C-derived. C++ was developed by Bjarne Stroustrup at Bell Laboratories. So, once again, it's the Bell Labs guys making all of these beautiful languages for us. C++ is an iterative improvement on C, crucially adding support for object-oriented programming, which again, C does not have. Object-oriented design adds the object, a new unit of abstraction that allows the combination of data with functions. This increases modularization and facilitates programming principles which allow very large programs to still be manageable. So, C++ programs can get huge. Much larger than a, yeah, if a library exists, use it. You're in Thode right now, does that count? Yes! So. Yeah, like, the Microsoft compiler isn't bad. Like, it runs Microsoft, but then again, Microsoft is Microsoft, and wouldn't you rather play with the big boys, you know? So, C++ is an interesting one because all C programs are, technically speaking, valid C++ programs. C++, you can think of C++ as a direct, I was going to say expansion pack, but in modern lingo, it's more like C++ is like the DLC version of C. It's got all kinds of more stuff that plugs into C. And in fact, so much stuff gets plugged into C that C++ ends up looking only marginally like C from a syntactic level. But yeah, every C program is valid C++. So, here are some other C-based languages. Objective-C is an object-oriented language developed in the early 80s and eventually acquired by Apple. So, Objective-C is Apple's version of C++, basically. It's objective because it has objects. Ha! I beat you to your joke. Yeah. Java is C++ derived, and it developed by Sun Microsystems in 1991. It uses the Java Virtual Machine to extend portability to a massive number of highly diverse systems and architectures. I have used in the past Java-based microcontrollers, for instance. Also Minecraft. C# is Microsoft's .NET framework. So .NET and C# are basically the same thing, if you didn't know that already. The idea is that it integrates internet connectivity into a framework of both Java and C++. So it borrows from Java, it borrows from C++, it tries to integrate all kinds of networking rigmarole. Non-Microsoft implementations of C# exist, such as the game object scripting language used in the Unity game engine. Yes, Minecraft! Some other ones include PHP, Python, and JavaScript. PHP is an object-oriented open-source scripting language used primarily in Internet database and Internet database applications. Because Internet database and Internet database are three distinct categories. I have heard that that PHP is quite an employable language. If you know PHP, you can sort of work as a web developer, although that information is probably quite out of date at this point. Python, which you guys should know, released in 1991, same year that Java was released, and developed by Guido van Rossum. Python emphasizes the elimination of superfluous syntactic detail, at least syntactic detail that it considers to be superfluous, and has become a very popular language for introductory programming courses. Despite the fact that the typing system is terrible, the object-oriented system in it is terrible if you compare any I often compare learning, like, programming in Python, if you're used to programming in other languages, is like getting constantly poked in the face by a pedantic asshole who's like, "Oh, that doesn't exist in Python because it's superfluous." That's what Python is like. So, JavaScript, most widely used scripting language, adds dynamic behavior to web pages. JavaScript and Java are not the same thing. Here is a comic about Java and JavaScript being not the same thing. Java is to JavaScript as car is to carpet. If you're interested in that comic, you can pause the video and read it through for yourself. So, compilers then. C-based languages are the ones that use semicolons. No. I'm quite sure that there are definitely languages that are not C-based that use semicolons. I'm trying to think if Fortran uses semicolons. Pascal. Yeah. Python. Yeah. You're gonna find out exactly what I think about Python as we do this course. And that's kind of funny because, like, one of the other courses I teach is like Computer Science 1 MD3, which is like intro Python programming for the computer science stream, and like they also know exactly what I think of Python, or they will by the end of the course anyway. They just make decisions that don't make sense, and everything's too loose. It's like, I prefer a good statically typed language. Like, I know some people think it's easier to program in a dynamically typed language, but for me, it's like, all it's doing is letting you get away with, like, not thinking your program through rigorously. Oh, no, Fortran, no, not that kind. No, Fortran was not developed by 4chan. Fortran is one of the oldest languages. It originally was written on punch cards, and it stands for Formula Translation. One of the very first programming languages, Fortran. Anyway, so, compilers then. In contrast to Python, which we all know and love from, 1D04. It's not 1D04 anymore. It's like 1P13 or something, right? C is a compiled rather than an interpreted language. So, with an interpreter, you feed a program into this process that is running on top of your CPU and interpreting the code as it's being fed into it. You can think of it like a giant grinder that's grinding up your code and turning it into flour for your CPU to actually be able to work with. Python is working pseudocode. That is codism. We should treat each code the way that we want to be treated. I don't have to treat... I am under no obligation to be nice to Python because Python doesn't have a soul, just like any other programming language doesn't have a soul, because it's a language. So, anyway, in contrast, when you program with C, what you have to do is you have to take your program and you have to actually compile it down to the level of object code which can be directly run by the CPU. So, a C program runs on the CPU with no intermediary. The only thing that controls the execution of a C program is the operating system itself. So this is how you compile, this is how you write a C program. Number one, you edit your program. That is to say, you write your program. Number two, you feed it into the compiler. The compiler performs pre-processing, parsing, assembly, all right? Linking optionally. So these 4 steps are all performed by the compiler. Steps 2 through 5. Then 6 and 7 are that's what happens when you load up the file for execution. You load it into memory, and then you execute it. So, editing a C file. C files may be edited using any text editor. Common text editors include Notepad or Notepad++ in Windows. You can also use VS Code. VS Code is a plain text editor with a bunch of stuff thrown in. That's why it's so much better than Visual Studio. On Linux, you have a plethora of options. You have Emacs, Gedit, Vim. You can use Nano. You can use... I forget the rest, anyway. And TextEdit if you're on Macintosh. Fancier environments, such as, Jupyter, VS Code, for example, allow for compilation of and execution of C programs within the editor itself. So, with VS Code, there's like a button that you click to compile. We're still going to go over how to do stuff from the command line, though, because doing stuff... basically, if you're a C developer, if you're developing C, the expectation people are going to have is that you know how to do at least some amount of command line operations. So we're going to do some of that this semester as well. So, C files are given the .c file extension. C header files, which we'll get to, are given the .h extension. And there's one other one, which is an archive, or a library in C, is given the .a extension for archive. So, invoking the compiler. Let me just open up a terminal here. Quake. There we go. Tab. Close tab. There we go. Go teaching app. To MP3. No. This is what Linux looks like under the hood, by the way. What are the command line operations? You should go to your tutorial this week. In tutorial this week will be... the next couple of weeks we're going to be doing this kind of stuff. Windows subsystem for Linux is enough. It's sufficient. We're also going to have the Pascal server open so you can log in remotely to the Pascal server using PuTTY or something. Yeah. Oh, no, CMD is like... So, okay. Important point of distinction. If you're on a Windows operating system, CMD, like the command prompt in Windows, that is MS-DOS, right? That's a completely different thing from what I'm doing here. It's not completely different in the sense that you're still typing commands, but almost all of the commands are different, because Microsoft had to have its own version. Pretty much everybody else uses Bash. Some, like, edge case Linux users use different shells other than Bash, but the overwhelming majority of Linux users use Bash. Yes. So, well, you should know how compilation works. I have a comment. I got VS Code to print Hello World in C. Is there anything more you need at the moment? You should know how the compilation process actually works. So I actually have a Hello World program right here. So there you go. This is from, previously. In order to compile it, GCC. The O flag specifies the name of the output file, so hello. Then you feed it the name of the source file, and then it compiles. And then to execute in Linux, it's // the name of the executable. You know it's executable because it's highlighted in green. Yes, there you go. So, what's happening on the screen right now is basically, yeah. So CD means change directory. Where can you find the assignments? Are they released on GitHub, GitLab? We're working on them. The assignments are currently in the process of being converted from their old format to the new format, and hopefully by the end of the week. I'm intending to have A1 released by the end of the week, this week. So, there you go. But yeah, we're going to have a we're gonna show you guys how to get up on GitLab. What about A.out? A.out is the default name if you haven't specified a if you didn't specify the output name when you compiled, then it automatically assumes that you meant A.out. So you can see that A.out is the same program. Is there any specific distribution of Linux I would recommend? If you're new to Linux, I recommend Mint, which is the one I'm running right now. It's nice and easy to get into. Try it out on a virtual machine before you wipe your computer, though. Linux is pretty lightweight. You don't need a whole lot for it. So, we have edited our program. To compile this program, we use the following bash invocation. GCC, simple.c out simple. It doesn't actually matter what order you put the tags in, so long as the next thing is the option corresponding to that tag. So you can put the source file up front, you can put it in back, so long as the name of the executable is followed by the O flag, then everything is fine. You'll get at least a week for assignment 1, possibly 2. So I won't make it due before you guys know how to submit it. Yeah, just learn the material. So the way that I like to organize my courses is kind of in a everything flows from the lecture material kind of a way. I won't test you on things, and I won't make you write assignments that have, that are dealing with stuff that we haven't at least tangentially done in class. Like, obviously, the assignments are going to extend the knowledge. It won't be exclusively what we do in lecture, but, you need to have picked up the stuff from lecture first. So, bash. Bash is a command line environment. So when I am doing this is all in bash. Bash, so you have your kernel. Your kernel is the way that your operating system talks to the hardware. You then have the operating system itself, which manages the kernel. Then you have what's called a shell. The shell sits on top of the operating system, which sits on top of the kernel, which sits on top of the hardware. The shell is the commands that you yourself enter. So, like, right now, I'm in a shell. Like, my desktop environment is a shell. It's just one that has a graphical user interface. This is a shell that does not have a graphical user interface. And Bash is the standard command line interface for Linux. And you can get it in Mac. So, good. So, first we invoke the GCC, the GNU Compiler Collection. GCC knows we want to interpret the file as a C program because of the file extension. Next, we specify the file to be compiled. The -O flag allows us to specify the name of the produced executable file. The produced file is the original program expressed in machine language, also known as object code. Note that this is different from assembly language. Assembly language is code that also gets compiled to object code. Although the compilation of assembly code is hypothetically a much, much shorter operation because it's already very close to what the computer natively runs. The compilation process. Once the compiler is invoked, it goes through a couple of stages. So, pre-processing. Once you take your C file and you feed it into the compiler, the GCC will run a pre-processing routine. This includes removing comments, expanding macros, expanding any included code, that is, any imported code, and a few other things besides. So, when you feed a program into the compiler, the comments are completely removed. The first thing that happens is all the comments come out. So that's why, with respect to there are no comments in an executable file, right? There's no annotation to it whatsoever. It's all been removed. So, if I've written simple twice somewhere, it's probably a typo. Oh, wait, no, here. So, one of this, simple.c, that's the name of the source file. Simple with no file extension, that's the executable. The default in Linux environments is for an executable file to not have a file extension. In a Windows environment, it's you append the .exe file extension. The file extension really doesn't matter at all. If I wanted to, I could write output hello.exe for executable, and you could still run it. .exe. There you go. The .exe works. It's just what you've chosen to name it. What are macros? We'll get to them later on in the course. There are character substitutions within the file. Parsing. The code is then broken down into tokens. This is also known as tokenization. The tokens are arranged into a hierarchical abstract syntax tree. So the program is broken down into a syntax tree. Assembly. The abstract syntax tree is used to create a series of machine code instructions which can be saved as a .o object code file. Then we link it. The object file is linked with relevant libraries and an executable is produced. So the linking phase, there's object code. So your program gets turned into object code. It may be referring to other object code files elsewhere in your system, either in the same directory or somewhere in your system's resource folders. So there's a linking phase which links up. It creates symbolic links between libraries that are stored in your system's resource folders and the executable that you're producing. So this is what that looks like in a blue Blockovision. So, compiler complaints. Your invocation of GCC may not end successfully if your code has bugs in it. So, syntax errors occur during parsing if the code cannot be parsed correctly. For example, let's take our get it hello.c. Does invoking the C compiler only apply in Linux? Because in VS Code you just hit run and it does it for you. Yes. So this is one of the reasons why I think it's better for you to learn this in a Linux environment rather than using VS Code, because VS Code hides this stuff from you, whereas in Linux it's obvious. So in Windows, the default is for it to append the .exe file extension that actually has nothing to do with the file itself. That's just how your operating system categorizes things. In Windows, it's .exe to indicate executable status. Whereas in Linux, the way that you indicate executable status, LSLA, is with a little executable flag on the file permissions. So anything can be executable. It just needs to have that permission enabled, which I think is also the case in Windows. But they do it explicitly with a file extension because because that's how Bill Gates decided to do it. So. Removing a semicolon constitutes a syntax error. So if I try to compile hello.c, I get an error. Error! Expected semicolon before return. There you go. So it tells you you're missing one. Then you go in and fix it. And then everything is good again. So in addition to getting syntax errors, return 72 just returns the number 72 to the process that ran the C file. So normally you return 0. Returning a non-zero exit status means that so if you return a non-zero exit status to the program or to the shell, that normally indicates a problem. So that's like an error code. So do I write the code in Notepad, save it as a .c file, and then run it through the command line? That's what I do. Yep. Can you use Linux on your Raspberry Pi? Yeah, probably a Raspberry Pi would have enough horsepower, for sure. Do I recommend fully installing Linux or just running it within the VM? If you have Mac, you don't need it. If you have, because Mac, you can already do all of this stuff using Bash. You might have to install GCC, but, I don't think you would. With Windows, you can either get the Windows subsystem for Linux if your computer is recent enough. So if you're running Windows 10 or later, just use the Windows subsystem for Linux. That's fine. If you're not, then you have two options. You can either run or you can run Linux inside of a virtual machine environment, like a VirtualBox or a VMware or something like that. Or we're going to have the Pascal server available for you to log in. So you log in via PuTTY or some other SSH client to our server that the school runs. You have to be VPN connected, but, so be it. And that gives you access to your very own Bash prompt, your very own user inside of a Linux thing, and we'll have instructions for all of that. In fact, I think I might have put instructions for that on Avenue already. Let me check. Maybe I did. Maybe I did. I was really hoping to finish these slides today, but y'all have questions. It's good to have questions, but, I was kind of hoping to finish the slides today. That's okay. We'll finish them tomorrow. Whoop. Did I have that already open? My goodness. All right. Resources? Ah, there we go. How to log into the Pascal server. I haven't checked with Derek to see if it's up yet right now, but here are instructions. So, yeah, these instructions need to be amended to include getting PuTTY. However, I believe, if I'm correct about this, that there should be instructions in topic 3. So a lot of these questions that you're asking about Linux are actually, they're answered inside of slide set 3. So be patient. Yeah. Secure. Yeah. PuTTY. There you go. What is the McMaster VPN? Just Google McMaster VPN UTS and you'll get your answers. It's a virtual private network. So the way that it works is to get access to certain. So, as a security feature, when you access certain computer resources from campus, it recognizes the IP as coming from inside of campus, and therefore you have a greater level of access to various university bits and bobs. Like, for example, the library. You don't have access to the library list. Like, you can't download library books electronically unless you're actually located physically on campus. The VPN, virtual private network, makes your computer look like it's on campus when it's not, so you can access the resources that are kept away from people who are not on campus for security reasons. And one of those is the Pascal server. So it's called pascal.cas.mcmaster.ca. This is not like, you're not required to code in Pascal. Pascal is also a programming language. It's just named Pascal. Because Pascal was a very important mathematician. Blaise Pascal. But yeah. So yeah, it's no, it's not a VM server. This is like proper secure shell SSH logging in. It's not a VM server. It's a proper Linux server. You have Git Bash on your Windows. Do you still need to get Linux? Do you have can you compile C programs on it? If you can compile C programs on it, then that's probably good enough. Yeah, we've moved a fair ways since Pascal was like one of 3 programming languages. Yeah. Good. Well, that's class. So if you have any further questions, I will answer your further questions. If not, we will continue this tomorrow at 10:30. Do I recommend installing Linux onto the machines completely or running it within a VM? Generally speaking, installing Linux on a computer generally means you have to take your hard drive and partition it so that you have a portion of your hard drive which is completely dedicated to your Linux like your Linux installation. This is what's known as a dual boot system, because you could boot either into Windows or you could boot into Linux. The problem with that is that if you already have been using your Windows computer for a while, your Windows computer will have stored some of your files to whatever space you want to make a partition, right? So the safest and most easy thing to do is to only install Linux on a brand new computer. That way you can guard against data loss. Of course, if you back everything up, then, that's also a way to do that, but, you have to back everything up. Back everything up if you're going to do anything with Linux that's not inside of a virtual machine, or the Windows subsystem, which is also a virtual machine by other means. Would you miss anything if you left for the tutorial? It doesn't matter because it's recorded. It doesn't matter if you miss it. Any advice on how to set up Windows subsystem for Linux? No, just Google it. From what I've heard, like, I run native Linux, so it's not really an issue for me personally, but I don't know, maybe somebody on Piazza would have some. That seems like a good question for Would Visual Studio Code work for C, or would you recommend getting Bash? I think it's better to use Bash because you're learning, and it's also important for you to learn how to use Bash. But, you know, again, if you use Visual Code to do the assignments, then that'll work. What are you supposed to have prepared for the tutorial? Yeah, it would be helpful to have Bash, but yeah, they're gonna talk about GitLab today a bit. Cool. All right. If that's everything, I think I'll sign off for today. Thank you very much, everybody, for listening to me ranting about C and how Python is terrible. Take her easy, folks.